Hello, differential equation students. We have here a second order linear homogeneous, because we have 0 over here, differential equation with constant coefficients, 1, -5, 6, and we're going to solve it. Now the way we're going to do this is we're going to make an assumption that y has the form e to the rt. Alright, so if we differentiate that, we get chain rule once, we get chain rule twice. Taking these expressions and plugging them in, what we get is r squared e to the rt minus 5r e to the rt plus 6 e to the rt equals 0. Notice that we can factor out the common e term. We get this. E to the rt is never 0. So what we get is r squared minus 5r plus 6 equals 0. And that's going to have a special name. That is the characteristic equation. So note the similarities between the differential equation and the characteristic equation. You've got the same coefficients. Cool. All right. It's easy to solve this. That factors is r minus 2 times r minus 3 equals 0. So we've got our two solutions, r equals 2 and 3. What that means is that the general solution of our differential equation has the form y equals some constant, we'll call it c1 times e to the 2t, plus some constant c2 times e to the 3t. We use both of those values of r's with constants out in front. Now we need to figure out what those constants c1 and c2 are, so we're going to need to use these equations up here. So since I have a y and a y prime, I'll find a y prime up here too. More chain rule. Woohoo! Okay, let's plug in 0. If we plug in 0 to this expression, we know we're supposed to get 4. And we end up on the right-hand side with c1 plus c2. Same idea, plug in 0. We know we're supposed to get 10 for y prime. And that's going to be 2c1 plus 3c2. And I can go through all the solving, but I'll just tell you right now, this is stuff that you can do for yourself. You should find c1 equals 2, and c2 equals 2. So we have the solution to this differential equation. Y is going to be twice e to the 2t plus twice e to the 3t. And that's our solution to our second order homogeneous linear differential equation with constant coefficients with those initial conditions. And again, the path is we find the characteristic equation, we solve the characteristic equation. That tells us the forms of the solutions. We have the constants out in front, and we use the initial conditions to solve for the constants.